Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to explain microwave laboratory components. And this is the microwave bench setup. The microwave laboratory delivers the necessary hardware support and software support in the area of RF engineering and microwave engineering. It focuses on the principles and advanced applications of microwaves by measuring the characteristics of microwave components using microwave bench setup. And this is the microwave bench setup. And this is the microwave bench setup. So please be very careful with the microwave bench setup, microwave bench test equipment, as it is very delicate and expensive to repair or replace. And what is microwave bench setup? A microwave bench setup is a device that helps to measure different values. Different values such as VSWR measurement, frequency measurement, impedance measurement, guide wavelength measurement, free space wavelength measurement, power measurements, etc. The microwave bench setup is a technical device known to conduct and regulate microwave devices. And this is the setup of the microwave test bench setup. So this microwave bench setup consists of KLYSTRON power supply, KLYSTRON tube with waveguide mount, cooling fan, isolator, attenuator, variable attenuator, frequency meter, slotted section, slotted line, detector mount, and VSWR meter. So this is the block diagram of the microwave bench setup with components. And first one is KLYSTRON power supply. So the KLYSTRON power supply is a regulated power supply for operating low power KLYSTRON. So before switch on the KLYSTRON power supply, we must follow some important points. That points are beam knob or beam voltage. This is the beam voltage. So this beam knob or beam voltage fully set in anti-clockwise direction or minimum position. And the second important point is the rippler knob. This is the rippler knob or the rippler voltage. So this rippler knob fully set in clockwise direction or maximum position. And the meter selection. So in this meter selection, there are three options that are voltage, current, and rippler. So before switch on the KLYSTRON power supply, this meter selection is put in current mode position. And after switch on the KLYSTRON power supply, the meter selection, the current don't cross 16 milliamperes. And the modulation. So this is the modulation. The options are in this modulation: CW, AM, FM, EXT. So before switch on the KLYSTRON power supply, this modulation is set in AM position. And frequency meter, amplitude AM and FM are fully set in anti-clockwise direction or minimum position. So this is the frequency meter. AM and FM are fully set in anti-clockwise direction. So before switch on the KLYSTRON power supply, so these instructions we should follow everyone. So KLYSTRON power supply generates required beam and rippler voltage for the X-band KLYSTRON tube. So the KLYSTRON power supply is very stable and contains the short circuit protection circuit. Also, it has amplitude modulation and frequency modulation circuit for the generation of 1 kHz square wave and the sawtooth wave. So that is the brief introduction to the KLYSTRON power supply. And next one is KLYSTRON mount. And this is the waveguide component of the klystron mount. So klystron mounts are used to transmit the microwave power from the reflex klystron tube to rectangular waveguide. And this is the rectangular waveguide. So transmit the microwave power from the reflex klystron tube to rectangular waveguide. So it consists of a movable shot and one end of the waveguide. This is the movable shot. It consists of movable shot at one end of the waveguide to direct the microwave energy generated by the klystron tube. It uses velocity modulation in order to transform continuous electron beam into corresponding microwave power. A klystron is a specialized linear beam vacuum tube which is used as an amplifier for high radio frequencies. And in the microwave laboratory, the frequency range of the in microwave laboratory, we can use the range of the frequencies X-band frequency. So that X-band frequency range is 8.2 GHz to 12.4 GHz. And cooling fan. And this is the cooling fan in the klystron power supply. So the importance of the cooling fan is it should be operated to reduce the heat for the reflex klystron. And next waveguide component is isolator. An isolator is a two-port device that transmits microwave power or the radio power in one direction only. An isolator is a two-port device which provides very small amount of attenuation from port 1 to port 2, and this is the port 1, another side is port 2. So to transmit the microwave power, minimum attenuation from port 1 to port 2, but provides maximum attenuation for the transmission from port 2 to port 1. An isolator is a non-reciprocal transmission device that is used to isolate one component from the reflections of other components in the transmission lines. An ideal isolator completely absorbs the power for the propagation in one direction and provides lossless transmission in the opposite direction. So these devices which offer low insertion loss and high isolation over 1 GHz bandwidth. For an ideal lossless or matched isolator, this is the S parameter. For ideal lossless, the S parameter S is equal to 0010. So an isolator is a two-port device. So the scattering matrix is S11, S12, S21, S22. So in isolator transmitting the power only in one direction from port 1 to port 1, it has small amount of attenuation. And the coefficient S21 is equal to 0. When the input is applied at port 1, there is no output at port 1. So the scattering coefficient S11 is equal to 0 and S12. So the scattering coefficient S suffix 12, the second subscript 2 represents the input port and the first subscript represents the output of the port. So in the isolator, transmit the power only in one direction. So the coefficient S12 is equal to 0 and S22. So S22, when input is applied at port 2, there is no output at port 2. So the scattering coefficient S22 is equal to 0. And this is S21. So the scattering coefficient S21, the second subscript 1 represents the input of the port and first subscript 2 represents output of the port. When the input is applied at port 1, it will get minimum attenuation at port 2. So for ideal lossless, the scattering coefficient S21 is equal to 0. And next waveguide component is circulator. So this is the circulator waveguide component. And what is a circulator? The circulator is a multi-port junction device in which a wave can flow only from nth port to n plus 1th port in one direction. And this is the 3-port circulator in clockwise direction. This is the port 1, port 2, port 3. So there are two types of circulators and their S matrix, that is clockwise circulator and counterclockwise circulator. And this is the S parametrics of the 4-port circulator. For 4-port circulator, the scattering coefficient S is equal to S11, S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. So when the input is applied at the first port, it will get output only the second port. There is no output at port 3 and port 4. So transmitting the power, transmitting the wave only in nth port to n plus 1 port. So this is the ideal circulator S matrix value. And next waveguide component is attenuator. This is a variable attenuator. Attenuators are required to adjust the power flowing in a waveguide and rotating this in anti-clockwise direction and clockwise direction to adjust the power flow in a waveguide. So these attenuators, variable attenuators provides continuous attenuation power up to 20 decibel. A variable attenuator helps set up the attenuator with the help of fine adjustment of values that one can check after getting the importance of the precision attenuator with the use of the readings. For a perfect matching, sometimes it is required that the microwave power in a waveguide to be observed completely without any reflection and insensitive to frequency. So for this reason, we can use variable attenuators. So the attenuators are commonly used for measuring the power gain or the power loss in decibels, for providing isolation between the instruments. And this is the variable attenuator waveguide component, and this is the fixed attenuator variable waveguide component. So the fixed attenuators provides fixed attenuation of 3 decibel, 6 decibel, 10 decibel, 20 decibel. And the variable attenuator provides the attenuation, continuous power attenuation up to 20 decibel. And the fixed attenuator. And 3 decibel fixed attenuator provides the fixed attenuation of 3 decibel. And 6 decibel fixed attenuator provides the fixed attenuation of 6 decibel. And similarly 10 decibel, 20 decibel. The next waveguide component is frequency meter. So frequency meter, which is used to measure, which is used for frequency measurement. So this frequency meter consists of a cylindrical cavity marked with a scale at its outer surface. It is a technical way. This frequency meter is a mechanical way of reading frequency. It is also called wave meter. With this frequency meter, the signal can be adjusted to its resonance frequency. So now here in this frequency meter, so measuring the dip frequency value of the reflex klystron characteristics. So now we are in this reading. This is the division value between the points is each division value is 0.005. So now here this point to this point 5 divisions are there. So 5 into 0.005. So 0.25. So each division is 0.005. And the next waveguide component is slotted section with probe carriage. Slotted section, simply slotted section or slotted section with probe carriage. So this slotted section device consists of a rectangular waveguide with a slot through its center as it's called slotted section. So this is the center. Once again, so the slotted section device consists of a rectangular waveguide with a slot through its center as it is called slotted waveguide. So it is the basic microwave equipment for study of VSWR attenuation, phase, impedance, etc. So the slotted section is basically used to measure standing wave ratio. So the slotted line section, it should cover the desired frequency and should be equipped with accurate scale. So rotating this one, we can measure the standing wave ratio value. Rotating this one is in forward direction, backward direction. We can observe the standing wave ratio values. And the next waveguide component is tunable probe. So tunable probe is designed to be used with slotted line section, and this is the slotted line section. So in this slotted line section, in this center portion, we can use the tunable probe. So tunable probe is designed to be used with slotted line section. So these are the meant for exploring the energy of electric field in a suitably fabricated section of waveguide. The depth of penetration into a waveguide section is adjustable by the knob of the probes. So a tunable probe helps in detecting the low frequency square wave modulated microwave signal. It is made by the use of crystal diode mounted in transmission line. And the next waveguide component is gun power supply. For gun-based bench, it is regulated power supply to operate the gun oscillator. This gun power supply also contains square wave generator to provide 1 kHz frequency to the pin modulator for amplitude modulation. And this is the pin modulator, so transmitting the 1 kHz frequency to the pin modulator for amplitude modulation. The next waveguide component is pin modulator. So this is the waveguide component of the pin modulator. So pin diode modulators offers an ideal way for amplitude and the pulse modulation of microwave signal through the wide range of frequencies. The next waveguide component is gun oscillator. So pin diode modulator offers an ideal way for amplitude and the pulse modulation of the microwave signal through the wide range of frequencies. So these modulators utilize pin diode which are mounted across the waveguide line a RF isolated DC bias lead passing through an external connectors. That is a gun oscillator. And next waveguide component is detector mounts. So detector mounts are used to detect the low frequency signals with the help of the detector diode. The detector diode is mounted on the broad wall of the rectangular waveguide. This is the broad wall of the rectangular waveguide. So the detector diode is mounted on the broad wall of the rectangular waveguide. A shorting flanger is used. A shorting flanger is used to time the maximum power near the detector diode. A shorter flanger is used to tune the maximum power near the detector diode. And the next waveguide component is matched termination. In making measurement of waveguide component, it is often desirable to observe the microwave power propagated down the waveguide. So these are designed in such a way to observe the maximum power, to observe the maximum energy without having appreciable reflection, assuming low voltage standing wave ratio value. The matched load is a microwave matched termination at the desired characteristic impedance, either 50 ohm or 75 ohm. It is used to observe the microwave power. So that is the matched load or the matched termination waveguide component. And the next waveguide component is slide screw tuner, SS tuner. SS tuner is used for impedance matching in the transmission lines. A tuning screw, and this is the tuning screw rotating in forward direction and backward direction. A tuning screw attached with a microwave along with the carriage helps in the impedance matching. So this is the brief introduction to the microwave laboratory waveguide components.